The next problem we're going to discuss is called blending problem. Here we have a set of ingredients, and then we're going to mix those ingredients in different proportions to produce a list of products. And there may be some constraints within the production process itself, and usually this will be a cost minimization problem, but it could be a profit or revenue maximization problem as well. So let's look at the problem. Here we have an oil company that has 5,000 barrels of crude oil 1 and 10,000 barrels of crude oil 2. So there are two inputs coming in. Now we want to mix these two crude oils to produce two different products. So each barrel of crude oil coming in has some quality level points based on the quality of the crude. So crude oil 1, each barrel quality level is 10, and for crude oil 2 the quality level is 5. Now when we mix the two crude oils to produce products, okay, in this problem we're going to make an assumption that there will not be any blending loss. In other words, if you mix one barrel of crude oil 1, one barrel of crude oil 2 to produce gasoline, then you get 2 barrels of gasoline. But in practical terms, when we mix, there may be production losses, and we won't consider those production losses in this example. And we are producing gasoline and heating oil. Now gasoline sells for $75 per barrel, and the quality level for gasoline must be at least 8 per barrel. So you mix the two crude oil in such proportion that the product that you get out will have 8 quality points per barrel. And for heating oil, the quality that comes out should be at least 6 quality points per barrel. And these are the dollar amounts at which the two products, the gasoline and the heating oil, will be sold. So we want to now determine how to mix these two crude oils and how many units we need to produce of the two end products such that the profit is maximized and we stay within these barrel limitations. So let's jump into the Excel file. Okay, let's first format the spreadsheet. So here are these selling prices. So let's color code that as input. Okay. Quality level per barrel of the input. Okay, 10 and 5 for crude oil 1 and 2. Required quality level per barrel for the output for the products coming out. And these are the barrels available of the crude oil. Okay, that's input 2. Now our decision variable is how many barrels of crude oil 1 we're going to allocate to the production of gasoline, okay, of that 5,000 available, and how many barrels should go to heating oil. And same here, crude oil 2, how many barrels will be used for gasoline and how many barrels for heating oil. So that's our decision cells. Okay. Now when we add this way, we will get the total production. So number of barrels of crude oil 1 used in gasoline, number of barrels of crude oil 2, add the two and you get the total output, assuming that there is no production loss, there is no processing loss when we combine the two crude oils. Okay. If there is going to be a loss, then we have to multiply by the loss percentage and take it out. But here in this problem, to keep it simple, we are assuming that there is no production loss. So just the sum will give us the total number of barrels produced. And if you add this way, that will tell us how many barrels of crude oil 1 will be used in total. Okay. Crude oil used for gasoline plus the same crude oil used for heating oil. and that should be less than or equal to how many barrels are available. Okay. Now the quality points constraint. Now here we know that each barrel of crude oil 1 will give us 10 quality points. So if you multiply that with how many barrels of crude oil 1 will be used for gasoline, so that will give us the total quality points we get from crude oil 1 for gasoline. You do the same thing. So how many barrels of crude oil 2 will be used for gasoline, and you multiply that with 5. So that will give us the total quality points we will have in gasoline. So let's give a name for this. So we have to define name here. So we'll use quality points per barrel. Okay, for crude oil 1 and 2. Now if you do a sum product of that quality points per barrel with number of barrels that we'll be using, this will give us the total quality points that will be in the products that we in the gasoline that we are producing. And you copy that here, and that will give us the total quality point that will be in the total heating oil that we have produced. Now, how many quality points should be there? Well, if you take the barrel, the 8 quality points per barrel must be in the gasoline, and that times the total barrels that we will be making. Okay, this will give us 8 times this will give us how many quality points must be in the product that we are producing. So you copy that here. So this is your quality points that will be in the production. This is the quality point that must be in the production. So what will be there must be greater than or equal to what should be there. Okay. Now, revenue is a sum product of how many barrels we're going to sell with the selling price, like that. So let's give a name for this. Okay, and barrels sold, let's give a name there too. Then you get sum product of selling price with barrels sold. That will give us the revenue, and that's the objective that we have to maximize. So let's color code that like that. I'll put a line there. Now before we go to solver, let's give some names. So the revenue should be named here. Okay. Barrels used and barrels available should be named. Okay. Quality points obtained and quality points required must be named as well. And what else? So we have to now define name for this. Okay, we'll have to define this. So we will say crude blending decision. Okay. Now we can go to solver. We will need to maximize the revenue. Changing cells is that, and constraints or barrels used less than or equal to barrels available. That's one set of constraints. And then quality points obtained must be greater than or equal to quality points required. So those are the two constraints. Maximize revenue, crude blending decision is the changing cells, and these are the two constraints. non-negative, and then simplex LP, and we solve. Make sure that the solver has found a solution, and here is the solution. Okay, now we're going to do solve a table, sensitivity analysis. What if the selling price of gasoline $75 is the current price, and we want to do a sensitivity analysis for that. Okay, let's go ahead and open solve a table. Okay, go to solve a table, a one-way table, and our input is gasoline price per barrel, and we want to use sensitivity for $50 to $90 in increments of $5, and we want barrels sold of the two products, gasoline and heating oil, and control click revenue. So here, as the price per gasoline increases, then you produce more of gasoline and less of heating oil. Okay. Let's do one more sensitivity analysis, and that is for barrels available of crude 1. So barrels available for crude 1 is this. So run solver again. Now this time you change the input, okay, to that. Alright, and we want to go from 2,000 barrels to 20,000 barrels in increments of 1,000 barrels. And let's leave the output the same. So this is the input cell. Click OK. So you get barrels available for crude oil 1 going from 2,000 to 20,000, and these will be the product sales, and these are the revenues. So we can see what the sensitivity of barrels sold of gasoline to input. And if you want to look at the barrels sold of heating oil, so change to heating oil, and you see what will happen to production of heating oil as your input for crude oil 1 increases.